everyone. Welcome back to Spring into Math 7. I'm Mrs. Campbell, and today we're going to be talking about testing proportional relationships with cross products. Let's get started. Let's start by asking ourselves, what is a proportional relationship? Well, if two ratios are equivalent, they have a proportional relationship. It's pretty much as simple as that. It means that the ratios have the same basic proportions. For example, if you baked, I have it written here, 2 cakes or 20 cakes, they would taste exactly the same. Why? Because they have the same proportions of ingredients. How do we test for a proportional relationship? Well, there's a couple things we can do. We can test to see if two ratios are proportional by using cross products. We simply cross multiply the terms in the ratios, and that's how we can identify if they in fact have a proportional relationship. Let's try one. Do these ratios have a proportional relationship? 4 to 8 and 1 to 2. So the first thing we're going to do is set the ratios using this symbol where we have a little question mark and then underneath it we have the equal sign. And this means that the ratios may or may not be equal. So I've got it written out here. 4 to 8, or 4 over 8 with the question mark equal sign, and then 1 over 2, or 1 to 2. The next step would be to cross multiply. So I have 8 times 1 and 4 times 2. 8 times 1 is 8. 4 times 2 is 8. Does 8 equal 8? Well, yes, it does. And there we know that the ratios have a proportional relationship. All right, let's try another one. There are 9 girls and 12 boys in Mr. Roy's class. There are 20 boys and 15 girls in Miss King's class. How can we prove that there's a proportional relationship between the two classes? So the first thing we want to do is write the ratios in the same order on both sides because we want to compare the same things on the same side. So let's do girls to boys. So we have 9 girls to 12 boys equals or does not equal 15 girls to 20 boys. Now we will cross multiply. 9 times 20, and we have 12 times 15. 9 times 20 is 180, and 12 times 15 is 180. So the cross products are equal. Therefore, we know that the ratios have a proportional relationship. Okay, now I want to take a minute to talk about proportional relationships and the constant of proportionality. If you have equivalent ratios or rates, they have a proportional relationship. We've just established that. But let's talk now about the constant of proportionality. This is how much the rate changes each time. To find the constant of proportionality, we need to find the unit rate. We multiply the starting number by the constant of proportionality to get the ending number. Now I'll show you in words and then I'll show you with numbers, and that might make a little bit more sense. But basically, you have your starting number, you multiply it by the constant of proportionality, and in the end you get your ending number. Let's take an example. Let's take a look at an example. So we have 27 to 9 equals 6 to 2. We know that these are equivalent ratios because their cross products equal 54. Both 27 times 2 and 9 times 6 equals 64. So we already know that they are equivalent. So what we want to do next is find the unit rate. So the way that we do that, we do 27 to 9 equals x to 1. Remember, unit rate always has 1 in the denominator, and we're looking for what goes in the numerator position. Then we simply cross multiply. 27 equals 9x. Then we're going to divide both sides by 9, and we get x equals 3. Now let's do 6 to 2, or 6 over 2 equals 1, x over 1. Again, we're trying to find the unit rate for this ratio. 6, after we cross multiply, we get 6 equals 2x. Divide both sides by 2, and on that side, we also get x equals 3. Now we have our unit rate as 3 over 1. Remembering that in the unit rate, the denominator is 1. This is really helpful when you're trying to find the constant of proportionality because if you have found the unit rate, all you have to do is look at the numerator, and that is your constant of proportionality. All right, everyone, that just about wraps it up for this lesson. Thanks so much for joining us, and we'll see you next time.